All right, we're here with Brent Salisbury. Brent is a software alliance engineer. He's now at Docker. He has started a company called Socketplane, which was very SDN relevant. It started basically doing the networking support for Docker before it was acquired. And before that, Brent was at Red Hat, and he also writes a very interesting blog where he talks about a lot of things SDN. So today we're going to talk with Brent about network virtualization, Docker, Socketplane, and its role in SDN. So thanks, Brent.
Hey Nick, thanks for having me. It's pretty exciting. Like I've watched probably all of your videos because a lot of it's like the heroes that I watched growing up, and yeah, see, it's the first place I send people to for getting to know what SDN is and kind of getting a wide view. So congrats, and keep up the awesome community work. It's really important.
Thank you, thank you. So I took a couple. I'm going to ask a bunch of questions about Docker and Socketplane, of course, but I also asked some of the students and folks involved in the course if they had questions, and I fielded a couple there. And one of the questions that someone asked was, in your view, what are the kind of main differences between OpenFlow and OVSDB, and when is it appropriate to use one versus the other?
Yeah, that's great. I mean, it's an awesome question. So networking is kind of been composed of three parts over the years. So we've got a data path, we've got our data plane, we've got a management plane, and a control plane. So when we start thinking about there's different protocols kind of for each different plane. So when you take, let's just say, OpenFlow by itself, OpenFlow is concerning itself with where do I forward packets to. But if I had a port that needs to be modified, some kind of CRUD operation, updated or modified or deleted, OpenFlow doesn't have any concept of that since it's kind of out of its plane. So that's where a configuration management type of protocol like OVSDB or like netconf, or even the most pervasive one that is often, we discount it and scoff at SNMP, but the reality is that 98% of the world still uses SNMP on their hardware.
I see.
So OVSDB is really cool. It came from Ben Pfaff, Bruce Davey, and Martin Casado, like me and my partners that did the Socketplane Red Hat. So there's John Willis, who's like this amazing DevOps guy, evangelist, kind of godfather-ish. And then Madhu Venugopal, who is our CEO, who is a complete machine, and then Dave Tucker, who is just the most productive guy any of us had ever seen. So we all kind of looked at, we've all been tracking kind of the same people growing up, and so when we looked at Martin Casado, we always joked and called him God, right? Because him and McKeon really and Shanker dropped this bomb that really kind of started a lot of this. So OVSDB came from Martin and Bruce Davey and Ben Pfaff, and it's pretty cool. So it's nice because you can remotely configure these things, and rather than having like SNMP, which is a one-way thing. So I'm going to poll it. So every 5 minutes I'm going to poll it, or every 30 seconds I'm going to poll it. But that starts to have problems when it comes to scale, because if you've got tens of thousands of devices, the world's almost getting, the world's too real time now to wait on a polling cycle. So the nice thing of OVSDB is that it'll set up a channel, and as events happen in the data path, it's going to shoot that up and send basically a diff in the database. And so when you look at the structures of it, it's just a database that has tables that are for port, interface, bridge, and it's extensible and whatnot.
So you basically get this ability to do port configuration, among other things that a simple match action table that OpenFlow gives you wouldn't necessarily give you.
Yeah, and there's a project called OVN that they're working on right now. So it's starting to fill in some of the gaps where, one of the OpenFlow is really cool for starting out, it was everything centralized, controllers work, and my background was at a university for a decade. So we had wireless controllers, we had call managers. So it's in my head, it's well, we have controller-based stuff, right? Like when you have a wireless controller, everything's going to funnel through it. When you have a call that gets set up, there's a punt to this controller, and then the session gets set up. The problem arises is data center alignment of traffic has significantly changed. So instead of 10 years ago when 95% of the traffic left the data center and went through some central point, 5% of it was east-west, it's basically flipped on its head. And so the majority of, like, I think Facebook 97.3. So 97% of the traffic is east-west to distributed systems. So as systems start to decompose down into smaller chunks, each of those have APIs. Each of those have, rather than just monolithic software that. So the expense of running to a controller and then back down that hairpin every time started to hurt. So part of it is, I think, what scaled the internet for 20 plus years. I think we went pretty far to the centralized route, and now it's how do we start decentralizing things but maintain the same decoupling. So almost, I think what makes sense today is having a controller, let's say, on each endpoint that starts to be attractive. Local controllers, and then have global kind of management panes of glasses.
Yeah, makes sense.
It's the density really that drives it. And as you start talking about removing operating systems and replacing it with applications, now there's going to be some kind of multiplier there, and it's kind of an interesting one because the workload will be dependent on what that multiplier is of replacing OSs with applications.
Can you tell us a little bit about your experience with Socketplane? How Socketplane came about, where the idea came from, and then how you started getting tied into Docker, and what's that whole story? How did you get started, and when did you sort of start tying yourself to Docker?
Yeah. Well, so I guess the longer part, so probably 4 years ago, I think I remember listening to a podcast, Packet Pushers, and it had Matt Davey, and then a couple weeks later it was Martine, and these guys are talking about this crazy thing. I'm like, wait, I'm a CCIE. I know networking, and I'm sitting here, I was like, I don't know what any of these people are talking about. What is this? This is crazy. So that was what kind of started the bug. And then a couple years back when Open Daylight started out, that's where I initially met Madhu Venugopal. He was at Cisco at the time, and he'd been doing Cat 6K work, and I'd been using Cat 6K, so we the rest there, the Open Daylight community is really awesome. Certainly grateful to anything open source right now. It's just it's not a fad. I think infrastructure at that lower layer really needs, especially in these kind of disruptive times, it's kind of a place to start nailing down de facto deployments. And so last October, we saw this kind of gap in the market where, Docker is, the numbers of Docker are staggering. And there's a reason for it. It's just an awesome application. And we actually stumbled on it doing continuous integration. So what we were doing, we were working on OVSDB OpenStack integration with Open Daylight. And so we needed to be able to test, do regression testing against, basically all the versions of Open vSwitch. So traditionally, that would have been, maybe a Vagrant, and there's, this multi-gig download to load the OS, and it didn't fit well. And Tucker took OVS, plopped it down into a container. The dude did the Jenkins work, and it was like this beautiful. Every time you pushed a change, a Jenkins job would kick off and run tests against OVS 1.0 all the way up to, I think, we were at 1.9 or 2.0 from there. And so it's like the safety blanket that was nice, but it was that took maybe 5 minutes. So it's the speed of that tooling. I mean, it's pretty phenomenal. And then, so we saw that. Personally, I work for Docker, but like I don't think I've ever had more fun playing with an application than I have, in kind of just changing my mindset on how systems should run, because it's, traditionally it was, you'd leave an OS up for, let's say, 6 months to a year, and it starts to eat itself. And so there's this float in the system that, it happens to our laptop, right? You keep putting stuff on there, you make configuration changes. There's, you don't have the opportunity just to blow away the OS and reinstall. So really you start doing that on like hardware refresh cycles in a typical enterprise. And so now it's, do you need to restart a service, or do you just want to reset the entire process back to a default? So it's pretty awesome. Like, you just throw away.
It changes the. I mean, I think in one of your blog posts you talked about it, sort of like throwaway kind of systems deployment, right?
Yeah, and I probably I don't know, this is probably a lame thing to say, but I'm a network guy that transitioned into like hacking code, so I'm allowed to get away with being a crappy programmer. But being able to throw away, being able to reset the system after some, you process some workload, well, a lot of times the state of the system after that, the daemon or the process is going to, might be left in some kind of screwy state, or it didn't complete all the way through. And so now I've got to figure out, okay, I've got to basically come up with this, FSM, a finite state machine that's going to handle every single possible scenario. Now I just throw it away. It's like, oh yeah, if it got stuck in a bad state, who cares?
That's kind of interesting, actually. I mean, because I guess, I mean, I guess one concern is that in some ways you're a huge success story, right? You're an operating engineer who's kind of become a software developer, and I don't know, maybe the whole industry is going to go that way. But I think maybe what you say is interesting, because operating engineers don't necessarily know how to write bulletproof code or want to. Most of us don't want to do that, right? So what do you think that means actually for networking and SDN? Because I think one of the things that comes up is like, yeah, sure, you can kind of like write a software controller or program to control your whole network, but then you've just created a software problem because you've got a buggy controller, or something that's hard to check. So we don't really know how to write good software either. So, but I think what you just said is interesting, right? Because maybe we don't even need to write, fantastic bulletproof quality software if we do what you're saying. Can you say a little bit more about that?
Yeah, no, I mean, and it's really kind of my nights and weekends interest is kind of figuring out how to get the kind of traditional NetOps to give Docker run a go, because you'll start to see that, getting a feel for how cool it is and how easy it is to spin up, what can look and feel like an OS if you want it to, a bash shell with one line. I've got an alias that spins up, if I want Debian, boom, Debian. If I want Yum, or CentOS, whatever, like one line, and you're dropped into a shell, which is insane. Like, just the time scale, everything about the time scale changing is just pretty beautiful. But I think the exciting part, I think it starts lowering the bar. So DevOps today, you got to be a pretty smart guy to like go jump into DevOps, right? So you might not have to have formal programming background, anything like that, but you probably needed to be exposed to some pretty smart people at some point to start kind of working your way in, or just a long time of curiosity and how do I automate. So I think some people kind of organically get there too, but I think the bar is still too high. And I think every time that you start thinking about compute virtualization, if you have to concern yourself all the way down to the subsystem and how that's getting initialized, and so you start breaking out layers and kind of hiding. I really don't care about the OS. I don't want to have to worry about an OS. Like, that's just that thing that's there. It's no different from a BIOS or a CMOS at that point. And so I think we start lowering. So basically, I think you can start doing DevOps now if you know how to install software. Like, you can even do it on Windows now too, which is really cool. So like, if you can install software on Windows, now you can start composing those pieces into a system, and now you're doing DevOps. Like if you know some Bash, you're doing DevOps. And I just think that's like, wow, that's pretty cool. Because I can take, like the packaging aspect of it is amazing, because it's hard putting together like complicated software and then getting that to you and you having the experience that I want you to have. It's really hard, right? I mean, I remember me and Kyle Mestry at Open Daylight Summit, we're running around with like these flash drives from the Linux Foundation, like 6 gig, like here, download this and install VirtualBox.
Well, even teaching this course, right? I mean, we have like tens of thousands of students, and like, it's like, here, we want this environment, and it doesn't work, a non-trivial fraction of the time. So.
Yeah, well, and if you think about it, it's always the same things that people are getting hung up on. It's how they interact with the hardware.
Exactly.
It's the NIC. How do I, what NIC? What is it supposed to be bridged, or is it shared? And so it's because you're doing this ground up every time.
What do you think are kind of I mean, those sort of speak to the pain points of DevOps and software development and deployment a bit. As far as like SDN pain points or killer apps or something, what role do you think like Docker is going to play kind of in the short term? Do you see any sort of really quick wins where things are super painful right now in SDN, but now with containers, things are going to get a lot easier?
Yeah, absolutely. So it's a great question, and I think the first step is there's so much opportunity for innovation that that's what I mean. It's so much fun to use it because you really are kind of tapping this creativity, because there is no one way to do anything. Like you can, like as far as your imagination is where you can kind of go with it. So I think packaging, I mean, one thing I've been doing lately is just kind of packaging up these traditional like networking apps that are open source that probably took me a week or two to even install. I mean, I remember I used to try and install CFlow-D, 12 years ago, and it was RD tools, and it's the graphing, and so I could export NetFlow data, and that would take weeks, and then you probably don't even have time to get it done, or by the time you finally get it up and going, it's like, I'm exhausted. Or it's funny because you spend all this time putting together some kind of orchestration, and then we ping, and that's it. It's like, okay, I'm burned out now. I'm just gonna, I can ping another system, great. So I definitely think that being able to package that traditional stuff is just such a great place. I mean, I think I took iPerf 3 here recently and used something called Docker Machine that I'm pretty big on right now. What it does is so Docker Machine will go out to any cloud, public cloud, private cloud, your laptop, spin up a VM for you with one line. Another line sucks in the credentials for it. And then once you have those credentials, you've switched into that context, and now you just Docker run. So I've got a common interface between my laptop and either VirtualBox or VM Fusion running there, AWS, GCE. There's a pull request for libvirt right now, so it could be your local data center or OpenStack. I mean, it's pretty cool because it starts really. It's a great first step in kind of making some commonality between the cloud, because I think one of the things I remember from the operations days was like getting compute was hard, right? You have to go get a VM, you have to go get licensed. That right there is probably you're in weeks because it's in inboxes and there is no self-provisioning, and then you either forget about it or you forget to patch it and it explodes, or it's in the cloud and you just got billed. Your controller just walks back with a $2,000 bill and you're like, oh, I forgot that was running. Right? So now I can just basically set up and tear down anytime. So like the economics of how you'll be able to reduce on-demand compute is real. Like it's not like it's not flying ponies anymore. So that's pretty cool.
I also was struck, like, I mean, I sort of was poking through Docker Hub, and I'm kind of blown away by the number of sort of, as you sort of list, you also mentioned various kinds of network functions, configuration setups, firewalls, reverse proxies, all traffic shapers, kind of, you name it, it's there. I wonder what you think this means for I guess what some people might call NFV or something like that, right? Which, I mean, you wrote a blog post a little bit about this as well, and I think that word means, or that phrase means, different things to different people. But I'd like to hear your opinion on NFV as it's defined by industry. But I'm also I'd love to hear a little bit more about what you think about Docker in that context, because I see potentially a scenario where you've got those Docker containers instead of these giant monolithic VMs being dropped in as say the telcos might envision it.
You're absolutely right, and our partners are networking partners are all over it. I mean, it's because it's such a beautiful. So if you look at microservices, that's one of the big things that's really kind of, as part of that paradigm shift. Not to burn, I hate that's an overused term, but it's pretty disruptive, I think, going to this kind of disposable, process-based. Give me the app. I don't want to worry about the rest, and I want the app to be able to, it's on demand, fraction of a second, and it's up and going. So microservices, in my mind, is an FV because it's applications, it's elastic, it's running on commodity off-the-shelf servers. Like, so NFV is, I don't know, my definition, I guess, is just from I haven't read the latest iterations, so probably a little bit dated, but it's basically take those services that were probably in a black box, decouple them out, and drop them onto commodity off-the-shelf servers. Mm-hmm. And I do think there's a whole the hardware right now is actually getting pretty interesting. If you look at like Barefoot, there's one, like the P4 movement that like Rexford and McKeon are doing, or they've been writing about that. And there's some pretty interesting things. This idea that I need the same flexibility I would have in user space on a server. I need that exact flexibility on hardware. And so, the details are low, but it's, TLVs as opposed to fixed headers. And, if you and I want to have a conversation, we can define whatever the header space looks like, as opposed to, it being whatever somebody in the ITF or whatever. And I'm not bagging on the ITFs. There's lots of cool things there too. It's, but yeah, like that flexibility, because really at the end of the day, we're turning the edge of the network into servers. So if the edge of the network is a server, now you can start doing those processes. If it's a provider edge and they've got a customer edge coming in, well, instead of trying to get this box in line that's doing firewalling or load balancing or all the crazy provider services, now start peeling those off into compute. There's still some really hard problems there. Like, how do you get the traffic? So we can classify traffic just fine. We've been doing that with MPLS forever, right? You get effects set up on an MPLS edge, and it predetermines the path through the label path. So what needs to, I guess, be baked in next is, okay, here's where it needs to go for this service. So classify it and then ingest it and pump it into, some kind of chain there. I mean, it's hard though, right? Because you got this performance thing. You're talking about aggregations, and you're talking about hundreds of millions of packets per second, and doing that all, trying to. It can't just go through servers, and then it also has to find an endpoint. So whether it's, BGP setting a next hop, or whether it's OpenFlow with predefined rules, it's none of that's easy.
I see. So I guess sort of to summarize, like a couple of the missing pieces are just performance for high volume, and also steering the traffic through the containers themselves.
Yeah,
getting the traffic there.
I mean, this path steering, I think, has been one of the hardest things of SDN. I mean, I was doing 5 years ago working on NSF grants at the university here. That's, it's path steering. It's very attractive because you can, start baking in time and business decisions and, all these different, I mean, the work I closely followed your SDX stuff, same concept. I mean, it's hard to, are operators ready to deploy compute with their server or with their kit? Are they willing to attach it to a controller? That's a hard one too. I think in my perfect world it would be because I think Linux is kind of a low level. Like, I'm not sure that's the proper abstraction necessarily either, because it's kind of low level. Like, do you want to go into Etsy interfaces to define like your interfaces? I don't know. So like having a module system loader, basically, I think could be pretty cool. And so you start loading in and out your apps.
Mm-hmm.
But yeah, NFV is hard. I mean, it's, but it's a $5 trillion telco market.
Someone will figure out how to solve it.
That's right.
Yeah. Another thing you talked about, I mean, I guess sort of in the content, you mentioned it in a recent blog post too. You talked about sort of the holy grail, if you will, is sort of moving towards prediction, like putting doing things like load balance and other things based on sort of not just reacting, but just sort of prediction. I actually wondered your thoughts on that. I mean, do you think we're even doing a good job of reacting at this point? Seems like we have a ways to go there too, right?
Yeah, well, and I think the first step is getting the data, and I mean, while networking's catching up, we're still a little bit behind. There's still some gaps to fill in before we're kind of online with the rest of compute. So, the network data is a big data problem. I mean, there's probably more data gets lost in network transactions than in any other enterprise. And if you are actually capturing it, that's probably the highest volume data collection in your entire, like, out of all your systems. Because it's expensive, it's often centrally collected. So there's this data gravity concept that I think absolutely is going to apply to networking, and that's since it's too expensive for me to take all this network data and put it into a central point. Instead, it makes more sense for me to take compute and put it at the edge where the data is actually being collected. So that could be networks, it could be a drone scanning buildings in a city, and then either do some kind of summarization or logship or
do such kind of data processing systems exist now? I mean, there's certainly some stream processing things, but I don't know if they're capable of doing this kind of distributed high volume stream processing that you're talking about here.
Yeah, I mean, and I don't even claim to be anywhere close to a big data guy or anything like that. I mean, I was doing some stuff a couple months back playing around with NetFlow, and so it's basically I want to collect everything from the edge. So I want to collect everything on the edge, but I want it all to be pumped to a central, like, let me summarize that, roll it up, and then get it into a central kind of time series graph. And like those kind of things, trying to do that from scratch. Instead, how I start is I go to GitHub or I go to Docker Hub. I find somebody's Docker file that's already got this stack of, Graphite, InfluxDB, Grafana, all these tools are already out there. And then I can actually focus on, there might be a little bit of extra middleware that needs to be put in there. So I think once we have the ability to get compute rather than waiting on VMs to be provisioned from, or at least have some self-provisionable compute regardless of the medium, I think that'll be.
It seems like you also need a way of like pushing queries or queries, I guess, out to where you're collecting the data, right? I mean, I mean, it's almost like a MapReduce cluster or something, but your cluster nodes are distributed across the network.
Yeah, you're exact. I didn't quite get to the because the idea was to tune it also. So if you want either a different threshold or you're troubleshooting a particular edge node, well, I want to bump up and give me much more granular data. And like you said, there's lots of cool distributed tools out there, though. I mean, there's so much software out there on GitHub, it's insane. And like, we keep reinventing, there's some wheel reinvention, but it's exciting to think about the average network folks out there. Like, I'm going to go to GitHub and I'm going to look at this, and within a day, I'm going to have a new SFlow collector or Elasticsearch logging as opposed to whatever else. It's pretty amazing.
What do you think is going to be? I mean, let's presume that there's going to be some tipping point where networks basically look like SDN networks with lightweight containers running Docker instances with network functions distributed in various places in the network doing middle box types of things. What do you think is going to be? Do you think that's? I mean, I assume you think that's a reasonable outcome. I kind of think it is too. I'm wondering what you think the tipping point might be. I mean, one might be that there's some killer app that this is really going to you just cannot do something with the monolithic black box VM VM style approach. Another is that all the people running networks now just eventually retire. But what do you think is going to happen?
Yeah, so what? I mean, is there the killer app out there for the? Yeah, I still think so. I think simplification for starters. Like, I'm pretty, I'm not an overly complex guy. Like, I can probably make some decent decisions on technology just based on, is it simple or is it complex? And there's always reasons to be complex, and finding the right layers of abstraction to hide that complexity. I mean, that's kind of the genius that Solomon did with Docker. It's like, this Docker UI is beautiful because it's simple, but it's also, if you want to do more with it, it's that's available too. So I think just the simplicity. So I think as vendors start to make those more of kind of canned apps and packages, which I mean, they're out there working on that now. So I think if there's a focus on simplicity where in 15 minutes I can set it up, like, that's kind of my, like, if it takes me more than 15 minutes to figure out how I'm supposed to install your software, my ADD kicks in. So, because we can do it today, there's a lot of complexity associated with it. So when it gets to the point where it is, I used to hate the app, like, App Store and network, like, it's so markety buzzy, but I think we're kind of getting there, because SDN without compute orchestration, how do you do it? Because those being decoupled from one another, it's got to be pretty closely tied to the orchestration. So it's just another place where there's tons of room for innovation. I mean, the cool thing is hardware too. I mean, you got DPDK. I mean, the speeds coming out of that, I think we'll kind of see, the swing. We'll always see a swing back and forth between hardware and kind of software forwarding. If anything, I think there might be a little bit of a trend going back towards
hardware. Yeah,
just to kind of, I mean, because 100 gigs of, you need the cost of 100 gigs worth of firewalling or load balancing today in black box versus the same, in the future on compute. It's pretty disruptive. If you can offload that stuff, which isn't trivial, but I think as packaging gets better, I mean, a lot of it does come down to packaging for the network.
In your experience as a CCIE network operator, guru, shall we say, transition to DevOps, SDN, dare I say, software engineer.
God, yeah.
Do you have? I mean, it's sort of a positive case for probably lots of other people lots of other CCIEs out there. Do you have anything you want to say about that?
Oh yeah. Well, and the thing is, they're so smart. I mean, there's so many smart people that are in networking, and those skills, like in 6 months, you could figure out how to use some brand new language, and you can come close to some form of mastery, right? If you'd never touched a network, you don't. That's not going to happen. It's just there's nuances to it. It's millions of things happening per second that. I mean, the human factor of all this is the exciting part, and they're already out there doing it. I mean, it's too long a list to even go down. I think lowering the bar of entry for more is going to be important, and thus the reason I'm pretty excited about being able to package up. Here's a really cool thing you can do with an SDN concept, and here's 3 lines to run in order to get that up and running. Like that I think is, maybe that is kind of a tipping point. Sorry, it's a crazy cat lady here. Yeah.
It's on your blog too.
Yeah, they're these kids, man, keeping up with them. A lot of kitty litter. Yep. So yeah, that's I'm super optimistic for it though, because it's just not something you can learn overnight. And frankly, if you ask me, like, if you said to me, I would design a new data center almost. Well, let me not touch a data center. I would design a new service provider the same way I probably would of 5 years ago, and that's MPLS, VPNs, BGP, multi-protocol BGP. I mean, it's math right now. It just still is, because I've got to, like, whatever it is, you got to be able to walk into a data center, walk into a CO, unplug half the rack, half the kit in the place, plug it back in, and at some point it all needs to come back to where it was, and that's it's hard.
Mm-hmm. Mm-hmm.
My programming logic isn't going to get it there, I'll tell you
that. Yep.
But not to discount at all, like, I mean, the traditional SDN and protocols, I mean, you have to be there. It's their APIs, and that's how we program a data path. I think decentralizing it to catch up with the density that's on the horizon, I think, makes a lot of sense.
Mm-hmm. Yeah. One final question. It's kind of maybe, I don't know if something you've thought much about, but I mean, you did mention BGP, so I'll ask a question about sort of interdomain stuff. Do you? I mean, it makes a whole lot of sense for people to be deploying Docker instances in their own network. What do you think about sort of a network, an internet where Netflix could put a Docker instance into Comcast network? Do you think that would ever happen?
Well, and so we do it today with cloud, right? So we all put workloads into Amazon, but do we let them modify the infrastructure? No. And it's a tough. I mean, it's a tough. I mean, I remember that problem when years with. There's been a couple of, I can't remember the ITFs off, but they were basically APIs to call. I just talked to somebody at just the other day at the biggest of the big, and it was the exact same thing. I'm not going to say who, because he'll kill me, but he's like, well, one of them said we could use BGP for it, because I was actually talking to him about the opaque. There's a white paper from it was either Facebook or Microsoft, but it's opaque BGP community strings. So I can basically put a TLV that says, I'm going to send you a payload that has, it's going to be this length in the field, and you're going to set a marker to count down, and you'll know when the end of each frame is. And so he's like, well, we could put that into BGP. And another one's like, no, why would we do that? So I just think it's kind of religion. I think isolation and security it's hard. And are you ever going to give up control of your network for another? Yes, but there's going to be strict kind of rules around it, because there's too much money to be made otherwise, right?
Absolutely.
So if Netflix can go in or I don't want to say a name, but if somebody can go into a provider network and say, I want this time of day, and that can be automated, then the provider saves money, and the provider from not having ops necessarily having to do that by hand.
Yep.
Yeah, so it's got to happen.
So it's going to happen. We just have to figure out the isolation and security problems in the meantime.
I think so, right? And I'm not sure they're that huge, but yeah, when you start digging at the details, everything's huge.
Cool. Well, yeah, thanks a lot for chatting today. I learned a lot.
No, thank you. This was exciting. So appreciate it. Like, keep it up. Seriously, it's you know, the people, the caliber of people is incredible, and it's, you know, it's really kind of breaking down the thought leaders out there to mix in, to trickle down to plain Janes like me, man. So it's cool stuff.
Yeah, well, you're one of them. So thanks much.
Thank you, man. All right, take care.